Hey everyone, my name is George, and I will be going through question 2 from Fall 2020 61B Midterm 1. So the first part says, fill in the count char method below so that it counts the number of instances of a given character. For example, a count char of x on x should return 2, and we should see that that is because there are 2 x's right here, underlined right there. And count char zebra z, uppercase z, should return 1. Because there is only one uppercase Z up here. Yeah, you may use a maximum of 10 lines. Note these 10 lines, that's just some blank count. But essentially, to do this question, we notice that we have to go through all of the characters inside of this string to figure out, yeah, is this character the character we want? If it is, we need to increase the count. If it's not, we need to continue on. So how are we going to go about this? Well, there's a really neat note at the bottom right here. It says, reminder, s.char at 0 gets the 0th character of s, or the character at the 0th index. So knowing that, let's try to build this up from the bottom up. So we know that we want to go through all of our characters to count the number of times our given character appears. So knowing that, we need to first start off with a count variable and initialize it to 0. This is the value that we're going to be returning at the end, because this is the count that we figure out. So we can just start with there. And then now the middle part is kind of like how we are going to actually count up our characters, right? So we want to iterate through all of our characters inside the string. So that is for loop, for int I equals 0. I less than, so a is our string. We can access the length of our string with the length function. And then we can iterate with 1 each time. Now, what do we actually do per iteration? Well, each iteration, we should be checking the character at that given index. So we can access that character, right, with the reminder at the bottom. So a.char at of our index, which is I. And we want to see if that is equal to our given character. So that is just equals C. And we can use equals here because char is a primitive type. If it wasn't, we would have to use dot equals, as we talked about before in this class. So yeah, if it is equal to our given character, right, we want to increment our count. Otherwise, we don't care about what is going on, and we can just continue on with our iteration. And as simple as that, that is the solution for part A. So just to reiterate what we've done, we want to count the number of instances of this given character C that appears in our string. So we need to initialize a count variable to keep track of how many counts we see. We need to iterate through each of the indices or characters in our string A. So that's from 0 up until a.length. We want to check if that character at that index is equal to our character C. Because if it is, we need to increment our count here. If it's not, there's no else case. We don't need to do anything. We can just continue. All right. So now moving on to our second question, X comparator. Suppose we want to build a comparator, X comparator, that compares 2 strings based on the number of times lowercase x appears in the string. For example, an X comparator would consider exon to be greater than some axons. That is because exons has 2 x's and some axons has only 1 lowercase x. So now they just want us to implement this. Again, recall from lecture that the compare method of the comparator returns negative if the first argument is less than the second, 0 if it's equal, and positive if the first argument is greater than the second. So an example here that we have is compare axons will return a positive number because axons has 2 x's, whereas some axons only has 1 x. So knowing that, we have our kind of X comparator class. We know that our comparator here, this blank right here, is comparing strings. We can see that right here. So we can just put string here. For compare, again, we know that we are comparing strings. So we can take in 2 parameters, which call them string A and string B. And these are the two strings that we want to be comparing. Finally, how to actually compare and return our numbers? Well, if the first, right here, if the first argument is greater, we should return a positive number. If the first argument is less, we should return a negative number. Well, knowing that, we need to access like the number of x's, right? And we've actually just written a function to do that, count char. So now we can take advantage of that, and we can take notes like count char of our A string and our the character that we want, which is just X, right? And then we also know that we have count char of our B string and our character X. And knowing this, we need to know that this will give us the number of X's in the first one, and this will give us the number of X's in the second one. And so a neat little trick with Comparator is we can actually take the difference between these two values and return that. And so there, so we can turn this into one line and take the difference of these two values, right? And we can definitely go back and check this, right? So if the first argument has more X's than the second argument, that means this first count char is bigger than the second count char, which means we get a positive number, and that's what we want. If they are the same, the first count char minus the second count char will be 0, and then if the first argument is less than the second, that means this is smaller than this one, then a bigger number subtracted from a smaller number will give you a negative number. And so from that, we've shown that this statement will return us the appropriate value for any string A and B. Yeah. Moving on to count or char count comparator. Now we want to build a more general character. So in part B, we only looked at X's, but now we want to also include any other character that we want based on kind of like our input. So it says now suppose we want to build a more general character counting comparator whose constructor takes a count character as an argument and whose compare method compares two strings based on the count of that character. So for example, we create a new char count comparator with Z as the character that we want to be looking at. And so when we compare Mazzy and Laser, we see that Mazzy has 2 Z's, Laser has 1 Z, and so this should return us a positive number. So now looking at the question itself, again, we are comparing strings. So just like above, we can just fill this in with string. Now looking at this, we have an entire class. It says our solution has one instance variable. And so to think about that, when we create our char count comparator, we need to save the comparator or the character that we are passing in so that we can use it later. And that's kind of like what we do here. So to save it for later, we also need to initialize it somewhere. So here we can initialize a private char C to hold onto the character value that this object should be comparing with. Then we can just set that C equal to the given C in the constructor, and then finally move on to the compare. So this compare, you'll notice, is very similar to the one we did up here. This one is a specific case. We hard-coded the X. Now we don't want to hard-code it. We want whatever character we get. But you will notice that the code will actually look very much the same, except instead of X here, we are just putting our character C because this is the character that our object gets in. And so we can just take what we had from above, string A, string B, as well as return of A. And this time, again, instead of X, instead of hard coding an X, we want to use the character that we were passed in when we created the object. Just like that. We have our solution to part C. Pretty much the same thing as part B, except for instead of hard coding an X, we take in a character and we use that character instead. Okay, now finally, we have word finder. Now complete the following code that will read in all words from the words.txt file and return words with the most C's. So we have some kind of code up here that kind of like reads these strings and kind of like does this for us. The big thing to note is that there's a line right here that they want us to fill out. If we go to our find max function, we'll notice that this argument right here is actually a comparator. And so kind of like we did above, we know we are going to be comparing strings, so we can just simply put string in here for our comparator. For this question specifically, we are looking at Z's. So we can think about what we just created up here to take advantage of this to count the Z's. So in this line, we can create a comparator, the one that we had made above. So that would be new with our given character of Z. And this is because, right, we know we want to take in a comparator here, we know that this char count comparator implements comparator string, and we can pass in z as our given c as what we are checking. Now this find max will find the maximum string in the array of strings using the given comparator, right? So given our comparator here and the way that it compares things, we want to return the string out of all of this list of strings that has the most z's. We can assume it has at least length 1 and another strings for null. So these are kind of just like checks to make sure that we can assume these things, basically. So to break this down, we are essentially writing a max function to find out the maximum number of z's in like a given word, right? So if you recall, a max function has a basic structure of go through all the items, keep track of a current max. If this current max is smaller than the given, the current item that we're looking at, then we want to replace it. Otherwise, we want to continue. And so going off of that structure, there are a couple of things to note. First, we need to take note of our current max and work with that. So that is just string best equals strings of 0. So we can assume that at the very beginning, the first string is our current best, and we will start comparing with that, right? Then once we are done, we can just return whatever we found as our best. And now time to fill in the middle. Like I mentioned, we need to iterate through all of the strings, right? We need to check all of them and see, is this string bigger than the one I currently have? So that would be our for loop again, starting from 0, going until strings.length, and then incrementing by 1. Now that we have our for loop structure, right? We want to compare our current best, which is best, with whatever we get, which is strings of I. So with that, we can write, we can take out the value from the compare. So CMP, we'll just say value equals CMP.compare of our current best with the new item in the string. So that would be strings of I and our best, right? And if you recall from the compare function, if this strings of I is bigger than best, in this case, has more z's than our current best, this value will be greater than 0. And so if this value is greater than 0, right, we want to reassign our best because we know that our current best actually has less z's than the new one we just found. So that would be best equals strings of yeah, and then once we've done that, we've finished comparing our current string at index I, and we can move on to the next one. So we can close our for loop here. So just to reiterate, we need to keep track of our current best in the best right here, which we can start off as strings of 0. We need to iterate through all of our strings, all of our strings, and compare that string with our current best. If it is better or bigger, in this case containing more z's, we want to replace our current best, right? Just like our max function. So we use compare here. If strings is bigger, the current string, right? We know that value is positive. Value positive means that this strings of I has more z's than our best, so we want to replace our best, and then we return our best after we're done